So, Lockheed Martin conducted a burst test of our expandable inflatable habitat that greatly exceeded expectations, bursting at 285 psi, 6 times the maximum operating pressure. These inflatable habitats will provide astronauts with a safe environment for work in deep space. Okay. Okay, that's going to get loud. So headphone users. Headphone users. Headphone users. Woohoo! 'Nice. Yo! .285 psi is, that's a lot. So, what's that in bar for everybody else? So, 285 divided by 14.7. 19.3 bar, which is, yeah, that's a lot. 19 bar. All right. That's okay, so that's good testing. You know why that's good testing? Because that basically shows that the only way that the thing will ever pop ever is if something blows up inside of it. And even if something blows up inside of it, that might not even be enough. You could pop a balloon inside of this thing and it's really not that big of a deal. It's pretty good, man. Pretty good. 19 space bars, yep. That's the pressure of 19 atmospheres. That's what 19 bar is. Yep. Spotted in this picture. Peep the desk. Okay, what am I looking at here? This is on the well deck of the Portland, I'm pretty sure. Peep the desk. Okay. Oh, guy's got a Brita filter. All right. Above the white helmet. Oh. Thin mints? It's big enough, Clayton. Yeah. The thing next to that, a bottle of water. This is fine. Oh. Neat. This is fine. Yeah, I don't know the factor of failure there, extra visual, but yeah. Cool. What did somebody do to the back of that television? Jeepers. Anyway, that's pretty cool. That's coming from Lockheed for their inflatable module. And then over here, Sierra Space is doing something very similar. Whoa. Okay. Yeah, TJ, if the pressure inside gets to that level, you got a lot more things to worry about than the thing popping. Yeah. Yeah, that's a good rule of thumb. If the internal pressure exceeds the amount of pressure to kill someone, right? And it fails after that, then it's pretty safe. I mean, that's pretty safe because you're going to have other things to worry about other than the thing popping. Oh, that's where they are. Test stand at Marshall. Next to that. That's an XS1 fuel tank, guys. I'm wondering, Thomas, if Lockheed's in a... Oh, no, they're not. Lockheed... Okay, so this is out in California. They're at a former test stand. That's what this thing is. It's an old test stand. Is it Colorado or California? But either way, that's an old test stand right there. See the deflectors? It looks like Denver. Yeah, sweet. Oh, yeah, it says Colorado right there. Nice. All right. I can read, I swear. One more time. It says Colorado at the beginning of the clip, guys. Don't worry. It says Colorado. It's okay. That's funny. All right, so a lot of inflatable testing. Interesting. So popping it is an issue. What about a puncture test? Why would they be doing a puncture test when they're doing a popping test? You don't test two things at the same time. That's dumb. That's not a good way to get a good handle on what you made. You test one thing at a time. I.e. the puncture test, they're probably doing it. They're probably doing something like that. They're probably not going to do it at the same time where they're testing internal pressure. You know what I mean? I don't think he was suggesting doing it at the same time. Guys, don't be an Aryan cast. For the love of God. I know. Never mind. There's too much cringe. There's too much cringe today. Boeing expanding SLS core stage production to KSC to build Artemis inventory. So this is a Phil Sloss article coming from NASA Spaceflight. Let's see what we got. Boeing, the prime contractor for the SLS core stage, is adding 2 new work locations at the agency's Kennedy Space Center in Florida as the company looks to support increases in the production rate of the launch vehicle. The completed engine section structure for the 3rd core stage is being transported via barge from Michoud to KSC. So where Boeing will now outfit the most complicated element of the SLS inside of the space station processing facility. Interesting. After the rest of the 3rd core stage unit is completed at Michoud, it will be barged to KSC, where final assembly will be moving to High Bay 2 of the vehicle assembly building. Interesting. The large volume of the VAB will allow Boeing to store completed stages without interfering with continuing production, which frees up more space at Michoud to expand operations there for production of the new exploration upper stage for the next generation of SLS vehicles. Yes. Yeah, serious, that's a reach, even for you. Character, don't agree with him. Why would you agree with him? He's an idiot. That's cringe, dude. She even chat sides with you? Oh, but does this timeout side with you too? L plus ratio. Sorry. What is it with you, Laser Man? Stop doing that. Oh, okay. So they're gonna move making engine sections of SLS to KSC so they can focus on EUS production. Yeah, okay. That's good, man. That's good that they're making room for it. I have questions and just they're genuine. Like, I got to talk myself through this real quick, and maybe it's It's probably explained a little more in the article. So let me, let me see what else is being explained here. Let me see. So, establishing KSC work sites to expand production. The initial goal of the SLS program is to reach a flight rate of 1 launch per year, but NASA and prime contractors of the vehicle studied for a long time on how to increase the production of boosters, engines, and stages to reach higher flight rates. Oh, geez, it's almost like I've been saying that for a little while. Boeing's expansion of core stage production to Florida was born out of these continuing discussions. NASA had asked us to do some studies on developing a process to deliver 1.5 cores per year, or 3 every 2 years, and up to 2 per year. Operations at Michoud are going extremely well. We learned a lot about how to assemble the vehicle, which it takes during Core Stage 1 and now Core Stage 2 builds. Successfully completing its first November 16th launch, NASA's Orion spacecraft on Artemis 1 went out to the moon. Okay, the Block 1 configuration of the vehicle, which launched Artemis 1, uses a modified version of ULA's Delta IV upper stage. However, NASA and Boeing are developing an in-house upgrade called the Exploration upper stage, which is also being manufactured and assembled at Michoud. The Block 1B vehicle will combine EUS with the core stage and boosters to increase translunar payload performance from 27 metric tons to at least 38. It's not enough. That's not enough. Boeing had to factor in the overlapping multi-phase production of both stages when considering how to increase delivery rates. We did facility studies with the addition of the entire Exploration upper stage set of tooling and assembly processes. It's a really tight fit to be able to get 2 core stages out per year. So we started looking around at our options. Shannon said that building new facilities at Michoud was feasible but pricey. We also wanted to reduce the overall cost of the rocket. We've been working on affordability a lot, so we kind of turned our eyes to KSC because there's some really top flight facilities that were being underused or not used at all. I was familiar with them from time in the Space Shuttle program and the ISS program. So we started talking to KSC and we worked out an opportunity for us to start using the Space Station Processing Facility. Nice. Shannon was program manager for both programs, serving as NASA's program manager for the Space Shuttle at the end of the program and as Boeing's ISS program manager before managing Boeing's SLS program. Okay. Beginning with Core Stage 3, Boeing is moving the outfitting and integration of all the main propulsion systems equipment inside of the engine section structure to the clean room environment at the SSPF. That answered that question. In addition, they will stack completed engine sections with the rest of the stage in VAB High Bay 2 after it's completed at Michoud and transported to Florida. We looked at the KSC expansion plan a little more and said that we're going to need a place to store core stages, and we looked at the VAB. High Bay 2 hasn't been used in a very long time, so we made a proposal to NASA to go do some demolition in High Bay 2, upgrade the crane, and build some pedestals in there. Why wouldn't you use High Bay 4 for that? It already has pedestals in there. Seriously, there's two pedestals inside a high bay 4, so you could hold space shuttle external tanks in it. Maybe it's not. They're not big enough because the core stage is quite bigger. Shannon explained that Boeing will use the space in High Bay 2 in two ways. One is to store finished cores in High Bay 2, and the other one is the ability to take the other 4/5 of the rocket and mate it to an engine section. No, High Bay 4 core is where they High Bay 4 is where they store SRB segments. That's where the SRB segments. That's where the SRB segments are stored before stacking. Okay, he's just talking about the pieces of the core stage. So he said if we can bring down some engine sections, do some integration in the space station processing facility, and then bring down 4/5 of the rocket completed from Michoud, then we can do stacking inside of VAB High Bay 2 and really shorten our production time. Boeing estimates both per unit cost savings and an increase in production rate. We're estimating around $50 million of savings per core, and we can do more than 2 core stages per year by utilizing the additional facilities.
Discovery, go at throttle up.
Admiral 39-month resub. Curious. Almost like the tooling for this could be made for doing more missions. Interesting. He noted that Boeing took the results of the study and the recommendations to NASA and their other stakeholders earlier in the year. We had proposed it to NASA over the summertime and said this is really the only way we can get a 2+ a year production rate. We asked to get the ability to get into High Bay 2, so Boeing said we'll take on the cost of doing the modifications on the High Bay. The space station processing facility really didn't have to do mods to, but we showed NASA that this is a better way to reduce the cost of the vehicle by reducing production time significantly. We're in a mode of trying to save costs now that we understand how to produce the vehicle, so NASA was all on board with doing that. Shannon said that Boeing also consulted with their stakeholders in Louisiana about the impact of the proposed changes at Michoud. We explained to them that this isn't taking any jobs out of Louisiana. It's actually increasing production rate at Michoud along with giving us the space to do the upper stage work. So we're going to end up hiring more people, so they're happy with it as well. It made sense all the way around. And then it was just making sure that we had all of our logistics covered to be able to ship engine sections and get the parts there and be able to hire the right team to be able to do the facility for long-term health of the program. This is a very positive move. Work to outfit engine sections with all their internal equipment and most of their external thermal protection system is already in the process of moving to the space station processing facility at KSC. Structural assembly of the engines will continue at Michoud in New Orleans, where all the friction stir welding and bolt assembly tools are in place. The engine section structure of the element consists of a welded barrel mating ring, bolted thrust structure. The barrel and ring are then bolted to the structure in a floor assembly jig at Michoud. Thousands of bolts structurally integrate to the barrel. The thrust structure while it's in its jig, and some secondary structures like brackets to hold electrical wiring and other equipment. Core Stage 3 engine section has completed its structural assembly at Michoud, and on December 4th, the structure was rolled out of the rocket factory in New Orleans onto the Pegasus barge and docked at Michoud to be transported to KSC. The engine section is not shipped with the bow tail on it, but it is shipped with all major structures in it and the thrust structure installed. So from a structural build standpoint, it's as far as we can go. When we would normally get a clean room environment, that's where we When we would normally get into a clean room environment, that's when we ship to KSC for integration. Huh. Hey, Elvis, what's going on, man? Huh. Space Station Processing Facility High Bay is a large clean room area for processing spaceflight equipment, which made it very appealing as a location to expand engine section production. It's a huge facility that is a 100,000 square foot clean room, and it has an airlock in the front of it where you bring large pieces in, clean them, and then you could take them into the clean room. We started thinking about that and realized that if we could do some of our final engine integration work there, then we would alleviate ourselves from having to build all the clean areas and areas that are all shrouded by plastic and such, that we have purges going on, which saves a huge amount of time. That's the reason why they're doing this. That one right there. 100K is the clean room grade, not size. Ah, okay. Thank you, Mappy. I didn't know that. I thought it was just slang for how big it is. It is a big space. That's it right there. That's the Space Station Processing Facility right there. It's quite large. Today I learned. Thank you. During the outfitting and integration of the first two core stage engine sections at MAF, the clean area enclosures were set up right around the flight hardware and would need to be broken down and then rebuilt to allow MPS equipment to be flown inside by a crane, so lifted and lowered. A large cover with the same 8.4 meter diameter as the engine section sealed up the top clean area. We've got that big shower cap over the top, and every time that we fly any hardware into the engine section, we take that cap off. And then when we fly the MPS hardware in there, then we put the cap back on. We have to go through the purge cycle to get it back to a clean room environment. You don't have to do any of that in the Space Station Processing Facility at KSC. Once it comes through that airlock, it's in a clean room environment, and you're able to do all the assembly and all your work. You're not waiting around for the purge system to do its thing. Great. Great. One 100,000 particles per cubic foot. Oh, okay, cool. Thanks, Mappy. I didn't know that, dude. Didn't know that about clean rooms. Today I learned. Once Pegasus arrives at the KSC turning basin, Shannon said the structure will be rolled off the barge and rolled down the road to the SSPF. We'll offload it, clean it in the airlock at the SSPF, and set it up in the tooling that is set up inside the SSPF and get to work on it. The engine section for Core Stage 3 is the first to be integrated at KSC, but Boeing has reserved floor space in the SSPF high bay for simultaneous work on a second one beginning next year with the engine section structure for Core Stage 4. The floor is marked out into 8 big rectangles. Right now, we've got rectangle number 5 to put all of our tooling, and then we've got the team with their computers doing ship side support, and they'll fill up that area pretty well. We can also do some offline work on the subcomponents that we fly into the engine section. Yeah, Stelphos, it is. And then next July, we're going to have Section 7, which is the farthest back rectangle on the right-hand side, if you're looking back at the wall. So 5 and 7 will be side by side, so we'll have Engine Section 3 and Engine Section 4 being built at the same time there. Yes. Good. The engine section, where the power heads of the 4RS-25s and all the supporting MPS equipment come together, is the most complicated element of the SLS vehicle as a whole, in the core stage specifically. At KSC, all the wire harness runs for electronics will be laid out and eventually interconnected. All of the pneumatic, hydraulic, and cryogenic tubing will also be welded and bolted together, along with the installation of instrumentation and avionics. Later in the integration, offline sub-assemblies like the 4 thrust vector control platforms that carry the hydraulic systems and equipment, and the 5 large helium composite overwrap pressure vessel bottles for the main propulsion system pneumatic system will be flown by cranes into the engine section for installation. The engine section will go through a standalone functional test, and then when it's ready to be made into the core stage, it will be covered up and rolled out of the SSPF and driven up the road to the high bay. VAB High Bay 2 has room for core stage storage and vertical stacking. Ooh. Well, the first engine section integration will begin in the SSPF. Boeing will also be working to outfit and configure High Bay 2 for final assembly of a core stage and storage of another. High Bay 2 was maintained as a hurricane shelter storage location for a completed space shuttle stack over the last decade of the program. After the shuttle was retired, NASA leased the High Bay to Northrop Grumman for integration of its Omega commercial launch vehicle. Cancellation of Omega in 2020 left the bay open again for a commercial partner, and Boeing is now working to turn it into a final assembly and storage area for core stages. I mean, imagine the HVAC system you need for a clean room that size. It's unbelievable. Here we go. Here's the question that I was wondering. During the Space Shuttle program, NASA had 4 storage checkout cells for external tanks adjoining the tower structure between High Bay 2 and 4. Tower B. Each of the 4 high bays is flanked by towers. High Bay 2 has Tower B on its north wall and Tower A on its south wall. Shannon said that some of the checkout cells infrastructure will be retained on the north Tower B side for storing one core stage. But Boeing will also develop final assembly processing cell on the Tower A side. On the North Tower B side for storing one core stage. Some of the checkout cell infrastructure will be retained. Okay. The diameter obviously is the same between the stages in the external tank, so we're going to leave some of the platforms in. There was an old mobile launcher platform that we're going to end up demolishing. And then we're going to have to fix up the crane, and we're going to have to build a pedestal.
Discovery, go at throttle up.
For the most part, it's not a huge amount of work. And we'll use both the north wall and south wall of High Bay 2 to fit 2 core stages in there. We'll use existing platforms and build scaffolding off of that to get access, and we'll have a really nice place to store our core stages kind of out of the way in the VAB, but also where we can work on them and get them prepped to be moved over to High Bay 3 when needed. Boeing spokesperson Megan Gessner noted in an email, Core Stage 3 Plus processing will be on the Tower A side and consist of a base pedestal system and multiple platforms to access the vehicle internally and externally. An additional pedestal stand will be placed on the Tower B side and have the capability to stand up a core stage vertically. This Tower B side will provide access to the engine section volume and partial access to other volumes internally and externally via various levels of existing ET checkout cell platforms. Boeing will work with a frequent partner, Futuramic, on the new tooling to support both vertical storage and final assembly of core stages. Shannon was planning to begin the discussion soon. I'm going to thank Futuramic for all the support on the Artemis 1 mission, and then we're going to go through the design of the pedestals and tooling. Boeing hopes to have initial tooling set up by the middle of 2023. The demolition contracts have been let, and I think that work will start pretty soon. Yep. Yeah, see, there's an external tank processing area right here. Old. Built during the shuttle program. I didn't know there was one in High Bay 2. I thought it was just 4. But yeah, they can hang external tanks in here. They used them for storage. So High Bay 3 is for where they put the mobile launcher. High Bay 1 is abandoned, basically. It has a space shuttle mobile launcher in there and all the gantries for servicing a space shuttle. High Bay 4 is for SRB. Now keep in mind, this is during the shuttle program, so these are not... This diagram is from the shuttle program. High Bay 4 is used for SRB staging to put into High Bay 3. And High Bay 2... right now is going to be used to assemble the core stage. We're finishing. Okay, so the initial use of tooling could be early as the third quarter of 2023, demonstrating the vertical storage capabilities of High Bay 2. Work continues at Michoud on hardware for the next 3 cores, including the completion of Core Stage 2 in the first half of 2023. We're finishing our final testing on the engine section. We'll rotate it right after Christmas. You take it over to building 110 and you add the big weights to counterbalance it. The engine section is rotated from its vertical orientation with its counterbalancing structure attached horizontally to it, and will be brought back to the final assembly area at Michoud Assembly Facility and mated to the rest of Core Stage 2. We'll rotate it, bring it back over, and after mating it to the rest of the stage, do checkouts, engine installs, and then all the final TPS work on it. And then the first half of next year, we'll be rolling Core Stage 2 out. That's well ahead of the need date for Artemis 2 for other reasons. So we'll take it to KSC, and it'll be in the VAB transfer aisle for a series of months. Well, it might be possible to store the completed second core stage that will be used on the Artemis 2 mission. There aren't many places, even at large facilities at Michoud, to put it without interfering with ongoing work on hardware for the third and fourth builds. It's a good problem to have, but we realize there's some pinch points in factory flow at Michoud to have multiple, almost full-size, 212-foot vehicles maneuvering around 70 meters. And so this is really going to help us. Even with the large confines of the VAB, storing Core Stage 2 on its side in the transfer aisle takes up a lot of floor space. Once the VAB crane for High Bay 2 is upgraded, and the new tooling is ready, the plan is to lift the stage, rotate it to vertical, and put it in the new storage cell on the north wall of the high bay. We'll do some work in the transfer aisle on Core Stage 2, but we'll stand it up in High Bay 2 and finish every bit of work that needs to be done on it. So when we lift the core stage over to High Bay 3, and we made it to the boosters for Artemis 2, it is a completely finished, ready to go core stage, and we don't have to do some of the work that we had to do on Artemis 1's vehicle. And all this was less complicated than just building more at Michoud? Hey, Envy, what's going on? Depending on the availability of the new storage cell and the integration schedule for Artemis 2, Core Stage 2 should be in storage in High Bay 2 for a few months or longer. To increase core stage production beyond the 1 unit needed for the initial flight rate, Boeing is looking to build a small inventory of these very large rocket stages in the VAB for NASA's Artemis launch schedule. We want to get ahead by a couple of cores from the manifest, and I think probably by Artemis 5 or 6 time frame we'll be able to do that. The addition of a second core stage production site at KSC will require an increase in workforce at both locations. We're really not impacting the workforce at MAF. We're actually staffing up there because when you do this, it enables you to get more vehicles in the flow. And if you have more vehicles in the flow, you need a larger workforce to do that. Michoud will still be completely assembling and mating the other 4 components. The other 4 core stage elements. And Boeing is adding the entire EUS production cycle to that work. The plan right now is to finish 4/5 of the rockets completely. And also to finish the EUS completely before we ship them to Michoud. Or ship them out of Michoud, excuse me. And I would even say there's potential down the road that we would have 2 engine sections in work at the Space Station Processing Facility and 2 engine sections in work at Michoud if we have a way to jockey the space around to support that. But right now, we think just from a floor space use standpoint, that would be a little more difficult to do. There are very few people that work at Michoud that work at the Michoud Assembly Facility that are moving to Kennedy Space Center. Most of the people working at Michoud like working at Michoud. We really tried to focus on hiring local talent in Louisiana. That's where they're from, that's where they like to work, so that's where they're staying. As Boeing transitions from design to initial production of EUS flight and test hardware for its first flight, they're looking ahead to have both liquid stages for the Block 1B vehicle in full production at the same time. We're increasing the number of people at MAF by about 125, and that's to support additional vehicles that we've got under flow, and also to do the EUS work, so they're fully staffed and going up a bit.
Discovery, go
Hey,
and
Hibbit.
throttle up.
Thanks for the 3 subs, dude. Boeing also has a large presence on the Space Coast with the headquarters of its Space and Launch Division in Titusville, Florida.
Discovery,
The
go
workforce
and
at
throttle up.
KSC will also expand. We've had a pretty good Boeing footprint down there supporting other vehicles like Commercial Crew, Starliner, or X-37. They're available to us, and
Discovery,
we're also
go and
hiring
throttle up.
people. Oh, and you need a more flare. Can the core stage be lifted vertically from one high bay to another? Or they have to lift it, turn it horizontal, and move it and set it back to vertical? That was my question, Creeper. That's why I said use high bay 4, but yeah, to my knowledge, yes, that's what you're going to have to do. They're going to have to take a core stage out of storage, lay it on its side in the transfer aisle, and then pick it up and move it into with the other crane. That makes sense. The one place focuses on making engine sections and what's mostly another engine section. The other place makes the big tank and attaches it. Interesting. Interesting. I mean, that all makes perfect sense. But I have a question, fellas. Why not just make the EUS at KSC and build the, you know... Actually, you know what? There's a better way to explain this. Or there's a better way to ask this question. So they need to really, with the engine section on SLS, they really need to, it needs to be in a clean room environment. That's fine. Won't the EUS need to be in a clean room environment as well? Because it's an upper stage? Why not just build the EUS at KSC? Rev, yeah, you're curious about that too. They could transfer from high bay 1 and between high bay 1 and 2 and 3 and 4. There's no easy way to between north and south. Yeah, you're adding additional movement. I'm trying to think of why they would do that. Why would you do that? Why not use high bay 4? There's a processing cell in high bay 4 and move SRB production to high bay 2. Feels like extra complexity to generate jobs. Well, yeah, Jack, that's not anything new with NASA. I think you're absolutely right. That's not anything new. NASA's supposed to do that. I don't mind more people working for NASA. Oh, that's nice, Creeper. Neat. Happy Fusion Day as well. Exciting times. Oh, yeah, they did Fusion at Livermore. My only guess is that they plan to change High Bay 1 for SLS stacking. Rev, I got a dumb question. Okay? If you will. I got another dumb question. So if that's the case... No, that doesn't make any sense. But that wouldn't happen until SLS 1, Block 1B. Won't that be a huge upgrade? So... Yeah, that... Remember the whole cost plus structure probably in the contracts. The extra complexity is probably contractually obligated. No. Maverick, if it was cost plus, why would the premise of this entire article be saving money? I don't think that's what's going on here, to be honest with you. And that whole bull crap that cost plus contracting is a sham is ridiculous. It is in certain it is in certain capacities, but in the case of SLS, it's not. It it wasn't for the longest time. The people get confused, dude. The problem isn't cost plus contracting. Cost plus contracting is fine as long as you have a deadline. That's where people have a problem. There's nothing wrong with cost plus. Cost plus is good if you don't really understand what you're trying to make. But what makes cost plus work is a deadline to get it done. You basically have a blank check, get it done in this amount of time. SLS didn't have that, so it incentivized needless spending. But now we have a time frame, so that's not the case anymore now, is it? What was that other dumb question? No, dumb question. That doesn't make sense to me. You might have to start asking around. Rev, why would we... Okay. I'm trying to go through why I don't like this. This is a good idea. They're going to be able to produce more SLS stages. That's what we want. That's what we want, right? That's what I've been pushing for a long time. But something about this is like, really? You're going to do... All right. I'd spend a moment to make a tank section upright stand that can shuffle back and forth between bays. As for the EUS production, it sounds like they took great pains to make sure Michoud understood they weren't losing any work. Seems like they might need to keep in good graces with some relayed people over there. Yeah, it's 20, yeah. It's to 20, 73-month resub. Thank you. Yeah, that's where I'm like, huh? I just got back. What did I miss so far? Yes, I know it's the third time today that I asked. Yeah, they invented VODs for this. You just scrub back in the VOD. You know what I mean? Like, we're talking about the decision to move the engine section production to Kennedy Space Center. Sounds like politics to you. I don't think... I mean, I think keeping the jobs at Michoud is, but... It's still just, like, Rev, what I don't get and what doesn't make sense in my head is why... Okay, so you're looking to move parts of the core stage production to Kennedy, right? To make room for the exploration upper stage production at Michoud. So why don't you just move exploration upper stage production to Kennedy? Why would you shift around what you already have? And now I think it was answered. I think it's because they've figured out better ways to do it. But why wouldn't you just move the U.S. production to KSC? He seemed to have hinted that they don't have a clean room to be able to build in Michoud. They don't have a clean room, and building a clean room makes no sense when one already exists and the infrastructure to get pieces there already exists. I think that's it. I think that they don't want to build a clean room environment at Michoud because they need one for the core stage. But now the question there becomes, well, you went to build this rocket and you didn't know you needed a clean room for the core stage? That must have been something that they learned that they needed during production. So use what you have, right? Or else they would have just built that from the start. So I guess that makes sense. I'm just like, you're going to manufacture the engine section in Louisiana and the tanks in Louisiana. And then you're going to move the engine section to get finished being assembled in Florida. And then you're going to move the core stage, the rest of the core stage, to be assembled in Florida. Like that. Are we sure that outweighs building a clean room? Isn't that going to get expensive over time? Did the shuttle engine section require a clean room? Yeah, the orbiter processing facility. Yeah, it absolutely did. The OPF is a clean room environment. Yeah. I don't know, man. I don't like getting into this thing where you start second guessing NASA because that's dumb. I don't know better, but also at the same time, I do have questions. Because I know they did this for a reason. I'm trying to hone in on the reason why. I think I got it.
Discovery, go at throttle up.
But how is doing all that cheaper than building a clean room environment? Because where I'm getting kind of like in my head, and maybe this is just from lack of information about the EUS because it's new. The exploration upper stage is going to need to be manufactured in a clean room environment. Most upper stages are.
Discovery.
Wicked! 10 subs, and then Victory with a 57. Victory, thanks for those pictures. Wicked, thanks for the subs. I do appreciate it. You're going to need a clean room to assemble an upper stage. Every upper stage is built in a clean room environment. Every single one of them. So this seems very much in my mind like an interim thing to do. But, yeah, I don't... Maybe I'm wrong. I don't know. No, they're not moving the construction, Aqualux. They were very adamant about not moving any jobs from Michoud to Florida. So that means they're going to make all the parts for the engine section, or for a core stage. They're going to make all the parts, save like for the engines, in Louisiana, and then assemble it. And then assemble it in Florida to make room for an upper stage to be made there instead. Why? I mean, that just goes back to what I was saying. Why not just make the EUS at KSC? Why not just make the second stage at KSC? Why are we splitting production of a critical subassembly? Like, you're trying to tell me that that's cheaper? Doesn't sound right. I did, Liam. Yep. Mm-hmm. No, the construction, the manufacturing of the stuff, Aqualux, is all in the same spots. It's where the assembly is taking place. Go back over it. If I recall correctly, they were transitioning people from building tanks to making the EUS. No, they're adding jobs for the EUS, Aqualux. This seems... Maybe engine section outfitting takes longer than constructing the EUS. Yeah, maybe. I'm not sure the EUS would fit in the space station processing facility, or at least in and out of the airlock door. But an engine section would? All right, let's go to Google Earth. Where's that airlock door? Let's go to Google Earth, Rev. We're going. Where's that damn airlock door? Zoom in on Kennedy here. Can a clean room be any size? Yeah, but it seems like NASA is very adamant about using what they have. Where's the space station processing facility? I'm pretty sure that that's the Neil Armstrong's operations and checkout. I think this is the SSPF over here. So Orions are made on this line right here. And so was the Apollo spacecraft, for what it's worth. So this over here is the space station processing facility, and that's the airlock door for the SSPF, and an engine section can fit through that. No, Aqualex, that I'm telling you that's incorrect. They're hiring more people for EUS production, and everyone is keeping their jobs. They're just switching assembly over to KSC. So the people that were assembling the engine section are going to work on the EUS with other people. So that door is 12.5 by 12.5 meters. That's, yeah. Yeah, it absolutely could. You could put it through there on its side, no problem. I'm away from the PC. Could you? Okay. Why don't you just believe me? Here, go ahead, see for yourself. I swear to God, Aqualex, if you go and read that article and in a half hour you type a paragraph into chat, I'm punching you in the face, like really hard. Don't do it. Don't do that to me, man. Don't do it. Don't do it. Don't do it. Yes, in the face. Don't do that to me, man. Aviator, why are you doing that to me, man? Make me change my damn hat. Don't do that to me. So, okay, here we go. Because I can. Why do you hate me? What did I do to you? Which one is the one that the astronauts come out of again? I think it's that one right there. Is there a shave the mustache channel point value? Man, hell no. No way. Okay. I'm going to have to ask around, dude. I'm going to have to ask around because I'm just entirely curious. Yeah, why would you move engine section? Actually, that doesn't make any sense. You know, honestly, I don't have a good answer. Okay, so like I want to be very clear. I understand why they're doing it. They're doing it so they can get production up and running faster. But this is going to end up taking longer than your current production in 5 years. If I'm just, call my stupid Factorio brain a thing. Like, doing it this way is going to end up taking a lot longer. It'd be better to have all the upper stage production done at one facility and all the core stage production done at one facility. But they don't want to do that because KSC has the facilities that Michoud needs right now. Someone from the 1980s is going to come looking for that thing, may have to fight for it. Yeah, well, Mustache gives me plus 30 to fighting combat ability rocketology, so it's cool. It's all right. It's like having the Infinity Gauntlet, but with facial hair. Right? You mean minus 30? No, I don't. You wouldn't know. You don't have a mustache. If you do have a mustache, shut up. What's that, Joe? On assignment today for Aviation Week here at Piedmont Triad International Airport, covering the Boom Supersonic Aero announcement. Oh, very nice. Very nice. Sweet. You have a goatee. That's like a mustache with extra steps. Like Samson's hair. It's the base of the power. Yeah. Sure. Anyway. Yeah, it's very interesting. I don't know why they don't just do that, because if it's a clean room that they're looking for, I'm pretty sure they're going to need one for the upper stage eventually, but like I said, it seems like a pretty hard stopgap thing. And the last thing the SLS program needs is stopgap, so I'd be interested to get some clarification on there. You see that the V-280 will be placing the Blackhawks for the Army. Yeah.
Discovery, go at throttle up.
Bye, guys. 65-month resub. If a tree falls in a forest and no one is around to hear it, does it make a sound, or does it just have a really bad case of laryngitis? I'm pretty sure that you lose your voice when you die. Bye, guy. And a tree falling over is the equivalent of it dying, so, I mean, A for effort on the joke. No, I'm not the ramen king. I don't have any ramen. I'm not so certain they made the best choice on that one. Doesn't seem to be as versatile as the Defiant. Rocket, here's what I said. And I did say this without knowing the V-280's, numbers. V-280 is really good. You can move people. I mean, you got a 2,400-mile ferry range, 800-mile combat range. It's like 750 if you average it out. It depends on what you're doing, right? Obviously, it depends on how many guys you have, etc., what cargo you're carrying. I understand the V-280's numbers. The V-280's numbers are impressive. But Rocket, there's one thing that spaceflight and I think, combat operations share in regard to each other. The thing needs to be as simple as possible. It needs to be simple. If it's not simple, it's going to break. And when it breaks, your troops are not as effective. Is this still a combat meta, or am I just completely off base? Alrighty, what I got from that, they're shipping it all anyway. Why not just use the unused clean room instead of building another one to do parallel processing? Well, Aqualex, they're going to need one for the second stage, dude. That's what I'm getting at. They're going to need one for the second stage anyway, so it seems like a stopgap measure, to be honest with you. So you're telling me they're eventually going to build a clean room at Michoud that's big enough for the EUS, which is bigger than the engine section, and make that there, and then build half of the core stage in KSC. Why don't you just build the EUS at KSC? That doesn't make any sense. They're really skirting around. They're really skirting around modifying a clean room, building a clean room at Michoud, but they're totally okay with retooling the entire VAB, like retooling an entire VAB high bay. I don't know. Anyway, it's faster and longer range, but the Blackhawk's legacy is its versatility. And that's why in real-world missions with Blackhawks, we always flew with a second set of choppers as backup. The ICPS is built by ULA in Alabama, Mappy. In a clean room environment, might I add. Yeah, I mean, Geeson, maybe. Yeah, Rocket, I don't know why we're... Dude, look, I love complicated systems like that. That's really cool, but I don't... Tilt rotors are awesome. They're really cool. I like the Osprey. I think that is a really cool piece of equipment. But the thing about Ospreys is that they've killed more people in non-combat situations than most flying vehicles that the Army uses. Actually, it's Marines. Marines are the ones that took the brunt of it, because when the vehicle isn't performing how you want and you just say send it anyway, it's funny. In spaceflight, they ground vehicles for that, but interesting. But yeah, I don't know, man. I think that's too complicated. It's too complicated of a vehicle. It's freaking huge. It's way bigger than a helicopter. So you're gonna need bigger facilities. Then again, it's the Army, so like it's not like you have to carry it on a Navy vehicle or whatever, right? Like you're not carrying it on like a LHD or an LPD or an aircraft carrier or whatever. The Ospreys have been grounded multiple times, yeah, because the gearbox that sinks the propellers between engine 1 and engine 2 really sees a lot of abuse, especially in fixed flight mode. Your propellers are synchronized. There's a synchronizer between them. And the clutch in that synchronizer really likes to not be a clutch after a while. The V280 is gigantic. It's a more complicated system. Yeah, you're paying for like double the range and stuff. But does Top Brass really think that outweighs the simplicity of a UH-60? It's more things that can go wrong, dude. Yes, they do, unfortunately. Most were in early service or combat losses that had little to do with Osprey versus Blackhawk. Not that the Osprey doesn't have issues. I understand that, Neuro, but you see most were early, implying that this has happened multiple times. How many times has the Blackhawk been grounded because the rotor drive assembly just likes to delaminate itself completely? You see that's what I mean, man. Like you're getting all this extra capability, right? For something that you're getting all this you have long range capability, you can get there fast, etc., etc. You're trading that capability because you have a bigger vehicle that's more complicated. I don't know, man. The Defy Next system just seems to fit the bill of what I did in the Army better than the Valor. Rocket, that's what I said. I agree with you. Why are we trying to why are we trying to replace what a helicopter does with what a tilt rotor does? Under the guise that it's the same thing. That's like looking at a fire truck and a smart car and saying, yep, those can do the same thing. Now, can a fire truck do everything that a smart car can do? Yeah, absolutely. Sure. Can a fire truck do more than what a smart car can do? Yes, it can fight fires. Is a fire truck more expensive than what a smart car can do? Than what a smart car is? Yes, absolutely. Way more expensive. Are there more moving parts on a fire truck? Yep. Except for parking in a small spot. Yeah, I know, right? They replaced the C2 also. Top Brass has a thing for replacing multiple aircraft with just one, no matter the downsides. The Defiant X system just seems to fit the bill. When it did, yep. Seems like 2 SLSs a year. They'd need the clean room to build, and a clean room to integrate. Well, they have plus a third to do the EUS. So it sounds like they're moving Bay 2 to EUS construction instead of building a third. Yeah, maybe. Who knows? The Navy has had to ground the Seahawk variants before, relatively recently. Interesting. I could see specific missions where the Valor would excel at, but for most things, Defiant. Yeah, I'm with you on that one, dude. And so, Rocket, the thing is that here's my next question. Well, not question. It's just kind of a thought exercise, I suppose. So they're replacing the UH-60 with the V-280. That's fine. Okay. And we're like, why would you do that? The UH-60 fits the bill a lot better. Rocket, that tells me that the bill has changed. The stakeholder expectations are different. Yeah, Aqualex, yeah. Can you link the article you were looking at in chat, please? Sure. Very interesting. I don't know, man. Rocket, if it was up to me, I think the Defiant is a much, yet you don't get the capability that the V-280 does. But you almost get the capability that the V-280 does. And it's a lot smaller, and it can fit in smaller places. How's that V-280 going to fit on a city street? New stuff from Sierra, excuse me. Yeah, we saw them pop the tank. That was like the first thing I led Space News with, Zay. Sorry. Should have told you. But yeah, that's why scrubbing through the VOD is important. I hear rumors that I want to scale down Defiant to replace the UH-72, which itself is a replacement for the Kiowa. Interesting. Yeah, there are smaller versions of it, Edmana. I think it's like the SBX or something. Yeah, Rocket, I figure I'd pick your brain, dude. It's almost like you have experience with Army aviation or something. It just doesn't make a lot of sense, dude. Army takes the Defiant X and the Air Force takes the Valor is what you expected. The VOD doesn't go live until the stream ends? You should be able to jump in, Wefrel. Or at least you used to be able to. Can you not do that anymore? Well, if you can't do that anymore, then that explains why everybody pops in here and asks me, what did I miss? You could totally do that? Oh, well. Yeah, okay. Interesting. Huh. I don't know. I don't know, dudes. It's just, yeah. I think the V-280 is cool. I like tilt rotors. Tilt rotors are cool. Personally, I think the Osprey is... I like the idea that the Osprey moves the entire engine. But the Valor is good too. The Valor has fixed engine design, and all they're doing is moving the tilt mechanism, or all you're doing is moving the swash plate and propeller assembly on the V-280. I mean, dude, you know what? Someone's probably thought of this, but Rocket, I look at that thing and I look at it in the desert. That thing will fail miserably in the desert. You try to land that thing on a desert helipad or something, like at a forward operating base or something. Sand is gonna go everywhere. You're exposing the machinery on the turbo. you're exposing the machinery on the tilting mechanism for the tilt rotor. So, oh great, now all your machinery is being exposed. Sand's going to go all up in that. You know how I know it's going to go all up in that? Guess what? The V280 has way bigger blades than the Blackhawk does. Dude, that thing's going to kick up like 4 or 5 times the dust that a regular helicopter does. Easily. And it's going to be loud too. Those blades like to Huey around, if you catch my drift. You have a few hundred hours flying on and jumping out of and rappelling from those things. Yeah. Interesting. You used to work until the VOD hangs. Alright, well, I'll have to check it out. Yeah, Laserman, I'm with you. I think they're more concerned with Taiwan than any desert location. I mean, I understand that, but yeah, it's just... Did I hear Tim Dodd correct? They are going to the moon in a Dragon capsule? I thought it was Starship junks unless information has changed in the past 48 hours. Yeah, I think the V280 is cool, and I'm sure somebody's put way more thought into this than I have, guys, to be honest with you, but... I mean, that's a stretch, man. It's a stretch. Pretty epic though that Tim is going to the moon. Yeah, no, that's super cool. super excited for him. That's really cool. So I found out that the V280 has a Chinook type transmission to where if one of the engines fail, the other one can keep the rotor spinning. The V22 has that too, Bandit. So Bandit, the problem is, all right. So a Chinook, that synchronization system between the blades, it works really well. The reason why is because the Chinook blades aren't moving at very high RPMs. It's like 300 RPM or something, 350, 400 maybe. It's not very high. Now, here's the thing. A tilt rotor needs to do everything that a helicopter can do, and it needs to be able to do more because those helicopter blades need to turn into propellers. When it's in fixed wing mode, your propellers need to move a lot faster. So you're moving a helicopter blade at a lot higher, or a kind of hybrid helicopter propeller blade at a much higher RPM. Okay? That breaks the clutch. That breaks that synchronizer. That's what happens with the V22. Your blades get out of sync and the thing goes into the ground. So the end result is that it has to be maintained a lot. You have to really put a lot of maintenance into it. The V280, I'm sure they figured out ways to make maintenance easier, but you're not beating physics at the end of the day. I'm sorry. You have those two huge freaking blades just spinning around, and when you're in fixed wing mode, when you're flying the thing around, guess what? This propeller, because the airspeed is different when you're taking a turn, is going to want to spin faster than the other propeller. That strains the hell out of the gearbox, because it's trying to make both the blades stay in sync, because if they don't stay in sync, the whole thing will rip itself to pieces. Now, like I said, with a Chinook, that doesn't matter. Chinooks don't, first of all, the blades don't tilt. They're on swash plates, and they don't spin as fast as the V22 or the V280. See what I'm talking about? The swash plate is what keeps them in sync? No. The swash plate is what allows the blades to be, allows blade pitch to be collectively increased or cyclically increased. That's how helicopters move around. But they're when I say they're on swash plates, I mean, don't get me wrong. The Chinook is on not the Chinook. The V-22 has a swash plate built into the design as well. So does the V-280 for what it's worth, because it wouldn't be able to fly like a helicopter if it didn't. It's the mechanism that connects them. It connects them together. That makes that it puts a lot of strain there. I know from V-22 mechanics that have told me about it. It's a pain in the butt to maintain. I don't understand. Like, I don't know how the V-280 is going to beat that problem. How are you going to beat that problem? And don't get me wrong, if they figured it out and they sold the Army on it and it actually works, then more power to them. Because that's the problem with the V-22. You have a real big physics problem to solve here. That's a big physics problem to solve. And don't get me wrong, there are people that are way smarter than me probably figuring this out. And once again, if they figured out a way to get that whole mechanism to work, like at least like even a 50% increase in like reliability, then the V-280 is absolutely worth it. Oh, absolutely. Sure. Yeah, the rotor desync on a Chinook bill is enough to rip the helicopter in half. It's time for you to model a Chinook for Microsoft Flight Simulator. You learned a lot about the V-280 in this video. Oh. Yeah. I don't... Yeah, okay. Oh, yeah, you asked Jared Isaacman a question. Oh, cool. Sweet. Good question, Creep. It looks like they drastically simplified the cross transmission. No dihedral. I wouldn't be surprised if there wasn't a clutch at all. The same way there isn't one for the H60 engines. Yeah, Aqualex, I don't think that's correct, dude. I don't think helicopter shaft speeds are anywhere near what the V-280 and the V-22s need to be. My concern with the V-280 is more of its footprint. It's far larger than what would work for the several missions you went on. Yeah, Rocket. That's where I'm kind of. Can we just go back to using Hueys? Like. No, don't go back to using Hueys. They got no armor. I really wasn't expecting him to respond, so it's a welcome surprise. Yeah, that's cool. Cool. And Aqualex, I don't think you'd have a solid drive shaft between both motors. I mean, maybe. I don't know. I mean, the reason the Chinook has a gearbox, right, is because you're taking input from the two turbo shafts, and then it's outputting to the engines. Just wondering why nobody's ever done that way. There's got to be a good reason. Doesn't the V-22 need to have the rotor sync? Anything that has two spinning blades, Maverick, needs to have the rotor sync, even if one is a tail rotor. Blades need to be synced, or else the thing ain't gonna fly. Or your blades are gonna hit each other. You don't want to do that. Trust me. I went on a whole dive into building helicopters for like 6 months in like 2017, 2018. Great pictures. Creeper, very nice. Yeah, you don't want to do that. Anyway. They do fly just down and fast. Yeah. All right, next bit. Next thing here. Well, Boom Supersonic has decided that they're going to try and build a custom turbine engine called Symphony. It's an interesting group of collaborators, but when you're basically starting from scratch on the engine, their current timeline, 2027 flight, seems challenging. The H60 drive shafts all spin at turboshaft engine speeds until they get to the main rotor head transmission. There's no slip between the turboshaft on the two engines, if I recall correctly. You need to turn one engine and the turbo disc on the other engine spins. Source regularly stood next to these things as they started up. Yeah. Okay. Wait, what are you talking about? Oh, I misunderstood. H60. No, I misunderstood what you were saying. Okay, so let me go back and read what you said again. Yeah. Okay. Do you think Artemis will hit the schedule for landing on the moon for 2025? Yeah. Yeah, I mean, Aqualex, you gotta keep in mind, just because they start one engine and the other engine spins does not mean it's direct drive. There could be a fluid coupling there. There could be a planetary gear. So there could be a bunch of different things, dude. It has to go through some type of gearbox. It has to. It has to go through some type of gearbox. And that gearbox is what wears the frick out. Doesn't matter. I mean, it does on the UH60 as well, but the UH60 is two engines driving one blade. The gearbox that you'd see on a V22 it has drive shaft output from the engine, from both engines, meeting together and synchronizing. So yeah, I mean, of course you get synchronization, of course, but the two engines are driving the propeller. The engines on a V22 are driving the propeller and driving each other. So if you get differential RPM, like when you're taking a bank turn, for instance, you're putting strain on that entire system. There needs to be some give. There absolutely does. The V280 isn't just replacing all the Blackhawks, it's replacing Apaches too. Why are we complicating things? Are we trying to lose? There's something, Rocket, there's something here that we're missing. This makes no sense. It's just like with moving engine section production to KSC. That makes no sense. I understand why they're doing it in the short term, but that makes no sense in the long term. I don't. Any one size fits all leaves a lot wanting in certain domains. They could use prop pitch to reduce gearbox torque in turns, etc. Possibly. Yeah, of course, Nero, if the system is built for that. I mean, yeah, that's possible. You're still going to strain components there, but like once again, I don't know better. What I'm getting at is there's something that the V280 does that we don't know about that would get them to believe it's good enough to replace a Blackhawk and an Apache. Now that the Apache I don't understand. Why would you get rid of a venerated system like that? That doesn't make any sense, but whatever. One of the Raider prototypes crashed in 2017, and I think that had an impact on the decision. Yeah, absolutely. Yeah. Can't wait to see it in the Potomac. Why would you do a tilt rotor? Why would you do that? Why would you do a tilt rotor? That's so stupid. I don't get it. I don't understand. The V280 must have some magical fairy dust inside of it because once again, that's a physics problem that you're dealing with. It's not and those problems where you just straight up can't beat it, you're beating against a brick wall, that is physics. You're not going to be, it's not an easily fixable thing. You're good? Oh, thanks, Jerry. You good? Yeah. No, you good. Yeah, I'm all right. I'm just there's something I don't really understand, but and that's what when I say I don't understand it, I mean I don't understand what the frick's going on. You're forgetting the cool factor. It's very important in deterrence. Yeah, interesting. Videos to go along with the boom stuff. Sure. All right, let's see what's going on with boom.
Symphony is a new propulsion system for supersonic flight, a boom-led development with world-class partners, but with every element of the design customized to Overture's needs, allowing us to maximize our dual goals of sustainable and economical supersonic flight. For example, we're able to extend time on wing by 25%, which translates into a roughly 10% improvement in the total operating cost of the entire airplane. It's a 35,000-pound thrust engine built around a medium bypass fan, which is quiet for takeoff and landing, yet efficient for supersonic cruise. It is the first engine designed for 100% sustainable aviation fuel. We're teamed with FTT, a unit of Kratos, for the Symphony engine design. By partnering with FTT, we're able to access the best supersonic engine design team on the planet with some of the same engineers that developed the engines that power the F-22 and F-35 supersonic fighter jets. GE Additive will be teaming with us to create additively manufactured designs for Symphony and to certify those to meet the FAA's stringent safety and reliability requirements. Lastly, we're designing Symphony from the ground up for low cost of maintenance, and we're doing that with the support of Standard Aero, our lead maintenance, repair, and operational support partner for the Symphony engine program. Powered by Symphony, Overture is still on track to receive type certification by the end of the decade in 2029. Overture will now roll out in 2026 and begin flight tests in 2027. When we look back at history, great airplanes, great rockets were always enabled by great engines, all the way back to the Wright Flyer, which is based around a new engine that the Wrights developed themselves.
Well, basically, when you got great engines and a great rocket design, you're going to get a great mission. When you got great players playing great football, you're going to get a really great football game. And there's one more. Let's see what we got. Yeah, it's the same video. I don't know what time on wing means. Rocket Guy, can you help me out with that one? Joe, I took photos of the boom presentation. We'll have to share them tomorrow when it's published. The engine plan for Symphony is very interesting, and I'm wondering if that arrangement with having 3 companies working together is viable. Yeah. After watching your stream today, my nephew's decided to get into aerospace. He wants to be a violinist to play music for all the intense videos. Time on wing means revenue flight time versus downtime for maintenance. Oh, okay. Okay. Taradra, thank you for the raid. What's up? Rabble, 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 rabble. So that's Boom Supersonic. Boom Supersonic is trying to reduce the cost of supersonic transport, and apparently they think a good way to reduce the cost of supersonic transport is to build new engines. Yeah, it's good to know, Aqualex. Neat. But you got to remember, that mechanism is not going to be similar to what you're going to see in the V280 and the V22. It's going to be different because you're dealing with different rotor moment. That's what I'm trying to tell you. It's the time between having to pull the engine off for wing swap or overhaul. Yeah, okay. So what is that? Low pressure compressor stages, high pressure compressor. Here, let me see if we can get a picture of that motor again. Boom was trying to get rolls. Yeah. But both refused, so they really didn't have an option. Yeah.
Discovery, go at throttle up.
Rocket Guy, is that contra-rotating staged axial turbine or stage axial compressors? When can we expect to see the EJ 2022 rewind? What? I was not working on that. I think contra-rotating would give you compressor stall. Yeah. Well, like, when they go here, go over here. Like, watch what happens when they show this. Oh, it's not contra-rotating. You have fixed on the stator? Fixed blades on the stator is okay. Idiot question. That's normal, right? Yeah, so you have, it looks like they have compressor blades on the stators right there, and then the turbine is on the rotating part. That makes sense, I think. The stator's always fixed. I know the stator's always fixed, numbskull. That's not what I'm saying. I don't know. Let's go. Here, let me see if I can see the whole thing again. Where are ya? Hang on. There was a picture of it. There was a picture of it floating around here. It's called Parsons turbine blading. Okay. All right, let's see what we got here. I wonder what that is right there. Why you have different stages between your compressor staging right there. Yeah, I got you, Neuro. Concorde engines were turbojets of the 50s and 60s. They're Olympus 593s with a SNECMA turbocharger attached to the back. Yep. Or afterburner, not turbocharger. Uncapping, 18-month reset, 2 years. Thanks for the great content, for putting up with my stupid questions and being an awesome dude. Have a good Christmas. Yeah, you too, man. Thanks for the resub. Yeah, your questions aren't stupid. My questions are. Okay. All right. I'm not really sure what I'm looking at with that motor there, so... That reduction is part of the compression stage. It looks pretty typical compared to other modern jets. That's what I'm asking. Okay. Yeah, so that was my question there. Is that low pressure to high pressure compressors? Yeah, that would be my guess. I mean, based off of what Chat was telling me there a second ago, yeah. During that video, every other blade set rotated. Yeah, you have some of the blades attached to the stators, and some of them are attached to the rotors. Interesting. What I'm trying to look at here is if there's really any what's the right way to say this? Are we seeing anything revolutionary here? Like, I mean, a medium bypass turbofan. So that means it's built for application, right? So not off the shelf, right? But this looks, I mean, there's your combustor right there. So long story short, you know, air goes in, gets compressed again, right? And then it gets put into a plenum, annular plenum, toroidal plenum, something like that. And then the air gets forced through these holes basically into a flamethrower. And then it gets shot out the back, and these blades turn. They turn the compressor blades, and some of those bigger turbine blades back there move the fan, and the fan gives you or at least half of your thrust. It's half jet engine. I think the medium bypass is why they're doing this way. Yeah, the medium bypass is there for a big reason. The medium bypass is there for a big reason, Rocket Guy. In fact, that's probably why Rolls-Royce said no. That's probably why everyone said no. The reason why everybody said no is because that doing that type of propulsion development for an airplane really only makes sense if you're going to do it in scale. Nobody makes engines like that. No one makes a weird medium bypass engine like that. What is medium bypass? So, Jim, with a turbofan, right? With a turbofan design, depending on the size of your bypass is dependent on basically where your thrust comes from. A low bypass turbo, so a turbojet is a zero bypass. So there's no bypass on a turbojet. All of the air that's going in through these compressor blades gets shot out the back and makes thrust. With a turbofan, that's a turbojet. With a turbofan design, you have a turbojet just like you did before. But that turbojet is shooting against a fan here, and that fan is driving an axle that drives the turbine back here is driving an axle that goes to the fan in the front. And the fan produces the thrust, hence turbofan. Most engines that fly today are high bypass turbofans, meaning that the fan is generating most of your thrust and the jet engine is generating a little bit of it. This right here is a medium bypass fan. The guy said it himself. It's a medium bypass fan. So if it's a medium bypass fan, that means that half of the thrust is jet engine and half of the thrust is fan engine, or something around there. It's more half and half. Modern turbofans are like 80% fan, 20% jet engine. If you're a pilot, then you know what I'm talking about. I'm talking about N1 and N2 turbine speeds, because there's two axles that can free float independently of each other with this thing. I don't think there's anything too special about this. It's just optimized for the application. Probably some recent material science upgrades will get folded in because it's a new clean sheet design. Yeah. But I mean, it's enough of optimization for application aqueducts that major airplane propulsion manufacturers don't want anything to do with it. So just take that into account, right? Like, it's doing something. Boom's expectations for this engine are pretty nuts. Interesting. All right. Shall we shuttle? Shall we? It's shuttling time. Mission mode 3, part 3. Because part 1